Hey guys, this is Fraser with Smart Tutoring. So today we're going to be looking at this, well, it's a combination of questions. It is logarithms, which is one of our favorite topics, and it's also sequences. So sequences in general, infinite sums, common ratios, but in the context of logarithms. So it's given this, the first three terms of a geometric sequence are given by ln x to the 9, ln x cubed, and ln x, where x is a positive number. And we have to find the common ratio. So how do we find the common ratio? Well, the common ratio is the, let's say, k plus 1th term or n plus 1th term divided by the previous term. So if we take maybe the second term, which is ln x cubed, and we divide that by ln x to the 9, we should somehow be able to work this out as the common ratio, as a number. So why don't we use one of the properties of logarithms, that we can bring that power down to the front. So that's the same as 3 times ln x divided by 9 times ln x. And if we simplify that, we can see the ln x's cancel, and 3 over 9 is simply 1 over 3. So that's the common ratio, 1 over 3. Now, of course, this just comes from one of the properties of logarithms that's given to you in the formula booklet. Now, the next part is solving this infinite sum. Now, you'll notice the infinite sum looks similar to what the geometric sequence that we have over here is. Okay, and actually I think we'll find that it's the same. So this sequence that we found is given by 1 over 3 to the k minus 1, because k starts from 1, times ln x to the 9. Well, 1 over 3 is the same as 3 to the minus 1 times k minus 1. So that's just going to be 3, distribute the negative 1, 1 minus k, times ln x to the 9. And you'll notice that in the sum, we have to find ln x. Here we have ln x to the 9. So we use the previous trick, which is we bring that 9 down. So 3 times 1 minus k times 9 ln x. And now a quick trick. 9 is simply 3 squared. And now we combine the powers. So 3 to the 1 minus k times 3 to the 2 is going to be 3 to the 3 minus k times ln x. Okay, and actually, if you'll notice that means that the infinite sum we're interested in here is just the infinite sum of this sequence. And the infinite sum, first of all, we'll notice the infinite sum actually exists. It's a convergent sum because the absolute value of r is less than 1. So that means that the infinite sum, k equals 1 to infinity, of this 3 minus 3, this, is going to be the first term, u1 over 1 minus r. This formula is in your formula booklet. u1 in this term is ln x to the 9. And then the common ratio is 1 minus, and the common ratio is 1/3. And we know that this is equal to 27, right? That's given in the question. I'm just going to highlight that so it's obvious which part is the question. It's given in the question here. So that the infinite sum is equal to 27, we have to find x. So that means 1 minus 1/3 is 2/3. We divide by 2/3 is going to be 3 over 2 ln x to the 9 should equal 27. So if we divide, if we multiply both sides by 2, we should get 3 ln x to the 9 equals 54, and then bring the 9 down, so that's 27 times ln x equals 54. And then 54 is, as we just found out, 2 times 27, so that means ln x equals 2. And that means that, remember that ln x is log base e of x equals 2, which means e to the 2 equals x. So x equals e squared, and that's the final answer. So it's quite a pretty question, it's quite a nice answer. And this is sort of a classic hybrid of different topics that they'll give you in. This is an AASL question, and it could even be a HL question, and it just shows how they can combine different areas of the syllabus to give you a question that sort of challenges you in different areas. So hopefully that was clear. It's quite fast, but if you feel like you need more help like this, then feel free to head over to ThinkSmart Tutoring. You can grab a tutor there very easily. You sign up. You can set your own lessons when it works for you. And as always, the teachers always have recommendations. I have recommendations for my students, but ultimately it's up to you and your parents about how many lessons you would like. And yeah, I'll be making more of these videos, so have a great day, and I'll see you guys soon.